Hello everyone, how are you today? I hope fine. Okay, first of all, allow me to introduce myself. My name is Lintang Ananta from Shipbuilding Institute of Polytechnic, Surabaya. Today, I'm here to present my final project proposal under the title Optimization of DLP type 3D printer parameters for dimensional accuracy and product surface roughness using the Taguchi biodirectional analysis method. The outline of today's discussion is introduction, research study, research method, and reference. First, about the background. The development of manufacturing technology is currently experiencing very rapid progress. One example of technological development is 3D printing technology. There are many types of 3D printers, one of which is the DLP or digital light processing type. This DLP technology has several weaknesses, one of which is that the print has a rough surface and needs to be smooth if you want the result to be as smooth as those of SLA, stereolithography technology. There are still many DLP type 3D printer users who only make guesses and rely on the default parameter as default setting from the CAM software, which make the print result less than optimal. Previous studies have tried to optimize various combination of process parameters to get the best quality object print. However, the optimization result from this parameter combination cannot be used on all types of machine because of the different settings for each machine and material use. Therefore, this study aims to optimize process parameters in DLP 3D printers machine slicer software to produce products with high dimensional accuracy and low surface roughness. In this study, the 3D printer machine used was Anycubic Photon Mono 4K. In the left picture, the material used is Anycubic plant-based UV resin, which is eco-friendly. This next. Why does this technology need to be optimized? Because to find out the best parameter settings to produce product with high dimensional accuracy and low product roughness using the LP technology 3D printing machine. Next. And the research problem of this study is, what is the parameter value of the combination of Z-lift speed, layer tightness, and exposure time on the plant-based Anycubic resin material which produce of the optimum product surface roughness value using a 3D printer with DLP technology? What is the parameter value of the combination of Z-lift speed, layer tightness, and exposure time on the plant-based Anycubic resin material which produce optimum product dimensional accuracy using a 3D printer with DLP technology? And the last one, what is the parameter value of the combination of Z-lift speed, layer tightness, and exposure time on the plant-based Anycubic resin material which produce optimum surface roughness and product dimensional accuracy using a 3D printer with DLP, digital light processing technology? And the research benefits of the study is, first, for public, it can be development in the field of 3D printing service entrepreneurship. And for further, research researcher can be used as a reference source of information and reference material for further research so that it can be redeveloped. And research scopes of this study is: first, this research is using a 4K anycubic photon mono 3D printer machine with DLP technology. Number 2, the material used is anycubic plane-based UV resin. Number 3, the design software used is Autodesk Fusion 360. Okay. The slicer software used is Photon Workshop CAM. And this is the previous research study as a reference in this study. The first we got from Andi Adisetiawan with the title Optimization of 3D printing parameters for dimensional accuracy and product surface roughness using the Taguchi gray relational analysis method. Number 2, Megatri Olimpias with the title Optimization of 3D printer machine parameter for tensile strength and product surface roughness using the Taguchi method pre-relational analysis. And number 3, number 4, and number 5 you can read on the screen. Why use Taguchi pre-relational analysis method? Because with Taguchi we can more efficient because it allows for research involving manufacture and a number of factory levels, make it possible to obtain a process that produces products that are robust and consistent with uncontrollable factors, produce conclusion regarding the response factor and level of controllable factor that produce the optimum value. And this is the research method from my study. Begin with start, then problem identification and formulation, then literature studies and field studies, then variable determination, then determination of degrees of freedom and orthogonal metrics, then preparation of tool of material, then experimental implementation, then implementation of experiment and data collection, then data analysis, then interpretation of experimental result, then confirmation experiment is in the prediction range. If no, we come back to experimental implementation, but if yes, we go to discussion, then conclusion and recommendation, and finish. And this is the research schedule of this study from January until June. And the last one, this is the reference for my research. Thank you so much. Maybe this is all for me. See you next time. Bye bye.